For today's notes, I'd like you to set it up with this title, 11-2, Surface Area of Prisms and Cylinders. We're going to set up our notes from the bottom, so I want you to count up 12 lines and draw a line, cut it in half, then 10 more lines for where I'm going to show you two different strategies for finding the area. And whatever's left over on the top, you're going to split it in half, where we're going to do the who am I and the definitions. The first thing I'd like you to do is in the left-hand side of the top part of your notes, I'd like you to write 3 words. I'm going to open this up a little bit so it's a little bit taller and easier for you to see. I'd like you to write a definition for vertex, edge, and face. Now I'd like you to have a word definition and also a picture definition. So let's take a look at what's on here. The word vertex is pointing to this corner. The edge is on this line, and the face is an actual two-dimensional shape of the 3D shape. So if I were to move, let me move this guy up a little bit. It says, a vertex is a corner, an edge joins one vertex to another, and a face is an individual surface. Go ahead and copy that down as I go through this page. So for example, a vertex is shown here. There are 3 different vertices. Here's an example of just the edges of that shape, and there's an example of all the faces. But again, what I'm looking for on the left-hand side is a picture and some words describing what a vertex, edge, and face are. Now we're going to be writing in some definitions, and we're going to define surface area, lateral area, and height. We're going to start off by drawing some prisms. So a prism, by definition, has 2 matching bases. So I'm going to draw a hexagon first. I'm going to draw a circle. I'm going to draw a parallelogram. Okay. Now to make these 3D, you connect each vertex to its matching vertex. That makes it 3D. Here's a cylinder, and here's a rectangular prism. And that's how you draw a prism. These are all prisms, and they're prisms because they have matching bases. And the name of the prism comes from the base. So this would be a hexagonal prism. This is a cylinder, and this would be a parallelogram. But if I wanted to define this parallelogram, let's say as a square, it would be a square prism, maybe a rectangular prism, depending on the angles down here. Now the height, by definition, has to make a right angle with the base. So these would all be heights right here. So a height makes a perpendicular line with the base. The next thing I wanted to point out is what the surface area actually is. Now, as you know, the surface area is basically the area of each individual face. So the area of maybe this rectangle, that rectangle. If I unfolded and counted each side and found the area of each one, maybe the area of, if I unfolded this into a box, all of those areas together would be the surface area. So we're going to go ahead and write that the surface area is the total area of the faces. And that's what would be the total area. But the lateral area is a little bit different. The lateral area, and I'm going to draw this in green so you can see it. If I were going to say find the lateral area, it would be only finding the area of the sides, not including the bases. So it would be just these side portions. So just this part of the can, not the top and bottom. Just this part right here. So I would call that the area of all the faces, but not the bases. Now there are 2 strategies for finding the surface area. We're going to start off by drawing a rectangular prism. So I'm going to draw that rectangular prism here. I'm going to draw that here. So here's this is a rectangle. I'm just looking at it kind of from the side. These are rectangles. Those are my bases. And then I'm going to connect corner to corner to corner to corner. So that's my rectangular prism. Now there are two different strategies for finding the area. One of them is to take out the net and to find the area of each face and then add them together. So for example, if I took this shape right here and I unfolded it, it might look like this. And I actually want you to draw this. So here's that long side, and there are actually 4 of these folded together. So if you imagine that you lifted this side up, and then this side and this side and this side, and closed it, it would make the lateral area, the outside part. But I didn't include the bases yet, so I'm going to put a little part here and right here. Those are all the bases, all the faces of this shape. So there's 1, 2, 3, 4 lateral rectangles and 2 bases. 1, 2, 3, 4, 5, 6. So if you found the area of area 1, area 2, area 3, area 4, area 5, and area 6, the surface area would be all those areas added together. It's a little bit longer, but this is definitely a way that you could find the surface area of this shape, plus area 6. That is one strategy. Another strategy is this one over here. So this is actually a formula. You might think it's easier, maybe it's more difficult because it has a lot of pieces here. To find the total surface area, you need to take the lateral area, so that's the area of the 4 outer shapes, not the bases, and then you add 2 times the area of the base. That makes sense. It's like adding all the areas together. But they actually have a trick for finding the lateral area. You take the perimeter of the base, so you add up all these sides, and then you multiply it by the height. What this really does is it finds this whole amount and multiplies it by the height. So it finds the area of like this giant rectangle, which makes sense. So let's label it. First I'm going to draw my rectangular prism again. Okay, there's my rectangular prism. So the lateral area, this would be the perimeter of the base. Let me get another color. Here's my height. It makes a right angle. So you would have to find the perimeter of the base times the height. That would give you the lateral area. And then you would only find the area of the base. So you'd find the area of this shape right here. And that would be multiplied by 2 because there are 2 areas. So these are 2 different strategies for finding the area of the surface area. One is by looking at the net, and the other is by using this formula right here. And basically, they're the same thing.